Now that we've talked about the sun, let's talk about the solar system and the planets around the sun, just for scale. So you understand how large the sun is compared to everything else. So if the sun was this size, then Jupiter, Saturn, Uranus, Neptune, and Earth is right there. Is the fifth largest planet, but it is pretty teeny tiny. And then if we were just looking at the planets, there's Earth compared to Jupiter, right? So many Earths can fit even into Jupiter or Saturn or Uranus or Neptune. So this is Venus, and then this is Mars, and this is Mercury. So Venus is just a little bit smaller than we are, and then Mars is quite a bit smaller than Earth. So reminder that we have our solar nebula, the sun, the star forms in the center, and then all of this around is going to go around and around and around, and they start to collide with each other. And the dust and the gas gets bigger and bigger as it goes around. It runs into more stuff, picks it up, and it keeps gaining mass until it finally clears its path. So this is our nebular theory, the theory that the sun and the planets formed from a nebula, right? And the planets first formed small shaped bodies called planetesimals. Eventually, they're going to become a planet. They become a planet when they are so big that they are rounded by its own gravity, right? The Earth is a sphere, and it has nothing in its wake. So as the Earth goes around in its orbit, it doesn't hit any large objects anymore. It's collected every large object in its orbit. So yes, asteroids do hit us, but in our path, we aren't running into large objects like planetesimals. Those are all clear. Now, planet actually gets its name from the Greek, and it was for a wandering star, because at night we actually see the planets pretty well, especially Jupiter and Saturn and Mars and Venus and even Mercury. And we see them move in the sky. They're in different places throughout the year. And so the Greeks thought they were just stars that moved in the sky, which we learned were not stars at all, but planets. So we have 8 planets. The planets are in 2 categories. The first category is terrestrial, which means they're made out of solid rock, and they're a lot smaller than the others. And that would be the 4 inside planets. We have Mercury, Venus, Earth, and Mars. We're all kind of solid rocks. Where the Jovian planets, which are also called the gas giants, are huge, are mostly made out of gas. They might have some sort of solid center somewhere, but what we're seeing is a bunch of gas in these planets. So then we have Jupiter, Saturn, Uranus, and Neptune. So you should try to remember the order of the planets, although obviously you're going to be taking an open note quiz. So this isn't so important, but we have Mercury, Venus, Earth, Mars, then Jupiter, Saturn, Uranus, and Neptune. So you can learn the mnemonic is my very educated mother just served us nachos. And you can actually find other mnemonics out there, but I like this one. Now, these things that are in the parentheses are called dwarf planets. That's because they haven't cleared their path, and they are not completely round just yet. So in the asteroid belt is a dwarf planet called Ceres, and then outside of Neptune are many dwarf planets. Here's just 4 of them that I've named. So a dwarf planet, it's orbiting the sun, but it's not quite round, and it has stuff in its way still. It hasn't cleared its path. And that's really what happened to Pluto. What happened to Pluto is we saw Pluto a long time ago and we didn't see anything else. But now we see all of these characters around Pluto, and we realized it's not really its own planet, but it has all these other things with it, so it hasn't cleared its path. Pluto also is not perfectly round, and it's pretty small. So Pluto got kicked out of our solar system in 2006 and was named a dwarf planet. But once we decided Pluto was a dwarf planet and we looked in our telescopes, we were like, oh, well, that's a dwarf planet. And oh, that one's a dwarf planet, and that one, and that one, and that one. And so then we found a lot of them. So once we decided a definition for dwarf planets, there's a lot out there. And so these are trans-Neptunian objects, which just means after Neptune, way out there. Now, a lot of planets have moons, not all of them, but most of them do. And a moon is something that goes around the larger object, right? So moons go around planets. That's the way it goes. And here we can see Earth has a moon. Our moon is called Moon. Not very creative. Mars has two tiny little rocks, Phobos and Deimos. Jupiter has, I forget, a lot, 30, but they have four big ones that you can actually see with a telescope. So like Io, Europa, Ganymede, and Callisto. Saturn has also tons of moons. Their main moon that most talk about is Titan. And then Uranus has moons, Neptune has moons, and then Pluto, we think it is Charon, which we are Charon. But now I think maybe Charon and Pluto are two dwarf planets. So who knows? That's just old picture. Anyway, the whole point is that the object with the largest amount of gravity is going to cause the object with smaller amount of gravity to orbit them. So planets orbit the sun, and moons orbit the planet. And that's how it works. So here's our solar system. So we haven't really going to get into this, but there is something called an asteroid belt between Mars and Jupiter. It's just a bunch of rocks and asteroids, and those do once in a while come out of orbit, head towards the sun. And if Earth is in the way, boom, slams into the Earth, right? Kill the dinosaurs. Jupiter, Saturn, Uranus, Neptune, and then we have more objects out here called the Kuiper Belt, which are kind of a little more icy because they're so far away from the sun. And that's where we find Pluto and those other things we saw. And then outside of that, we have even more ice objects that actually will come in, and these are comets. The comets will orbit all the way around the sun and then go back out, and they are part of what's called the Oort cloud.